Hello, everyone. Good afternoon, good evening, good morning. Welcome to today's training on the Crystal16 instrument. Before I introduce our application specialist that will share all the information related to the Crystal16, I would like to share with you a few technical details. This webinar, this training is being recorded and will be made available to all of you. I think in a few days you will receive a link where you can watch the recording again. It will be a link on our website or on our YouTube channel. The slides of this webinar will be available on our website to download. And if you have any type of questions, please do not hesitate to write them here in the chat function of this Q&A session. We will take all the questions at the end. We will also try to make use of the microphones and unmute each one of you that you raise your hands. So please make sure that you raise your hand and we will try to hear you out and have a live Q&A session. It will last about 30 to 45 minutes. If afterwards you still have questions, please write to us at info@crystallizationsystems.com or directly to jyoti.yadav@technobis.com. And now I would like to introduce Jyoti. Most probably some of you already were in contact with Jyoti. She is our application specialist since quite some time ago. Is working for the same for a few years on the Crystal16 and developments of new features for this instrument. And she has all the information related to the use of the instrument from both hardware and software point of view and application, of course. Here is the floor for you, Jyoti. You can continue.
Yes. Thank you, Carmen, for the introduction. Hello, everyone. As already introduced, I'm Jyoti, application specialist from Technobis Crystallization Systems. And today I will be taking this training session on Crystal16. So welcome to all. The aim of this webinar is to help you make most efficient use of your instrument, Crystal16. And if you have the latest version, V3, and if you have the older version, V1 and V2, this webinar will give you an idea what to expect by upgrading the instrument and what are the end user benefits. So this webinar will be focused on determining the solubility and metastable zone width, but we will have another webinar to measure the induction time and nucleation rate analysis with Crystal16 soon. So for this training session, let me use my pointer. So for this training session, first I will give an introduction about Crystal16. Already you are using Crystal16 for some time, but just for the warm-up, we will discuss what is Crystal16, how it works, and what are the different applications. Then we discuss end user benefits of the version 3, and it will give you a bit of comparison between the older version and the new version. Then we will go to the live demo, to the software, and learn how to program an experiment, how to do the tuning step, and how to analyze the result, which is most important. And we also look for some additional features like feedback control and multi-analysis, which will help you to improve the efficiency while performing experiment. And in the end, of course, we will have a question and answer session. So what is Crystal16? Crystal16 is a parallel crystallizer for medium throughput crystallization studies. It has 16 reactors with 1 ml HPLC vials as reactors, and it comes with 4 independent temperature blocks, where you can control the temperature between -20 degrees Celsius to 150 degrees Celsius, and you can even go to -25 degrees Celsius with the chiller for all 4 reactor blocks simultaneously. Then it has magnetic stirrer and the overhead stirrers in each reactors, then turbidity measurement in each reactors, and it comes with intuitive software which makes it easy to program your experiment. Then how it works on the transmissivity technology. The light passes through the light source through the vials, and it is detected by the transmissivity sensor. So the instrument measures the change in the transmissivity with the change in the temperature over the time, which gives you clear and the cloud point. So clear point is defined as a temperature upon heating, where first 100% transmissivity is obtained, which indicates the complete dissolution of the solute, that is clear solution. And cloud point is defined as a temperature where first 0% transmissivity, or you can say last 100% transmissivity is obtained, which indicates the appearance of the crystals. Then using clear and cloud point, these clear and cloud point, one can determine the solubility curve from the clear points and metastable zone curve from the cloud points. Coming to applications, you all are using Crystal16 for different applications, but this will give you an idea. Maybe you can use Crystal16 for other applications as well. The most common application is determination of solubility and metastable zone width. Then any kind of solid state screening, for example, co-crystals screening, salt screening, any polymorphic screening. Then induction time and nucleation rate analysis, the latest version, the software with the latest version, you can measure the induction time at different supersaturations, and it will determine the nucleation rate and nucleation parameter using the classical nucleation theory automatically without any manual calculations. Then you can use Crystal16 to check the effect of different experimental conditions like cooling rate, RPM, and do the hydrodynamic studies. Then you can draw phase diagrams for co-crystallizations, and you can do the solvent screening. As with Crystal16, you can determine different solubility curves in just 4 hours. So it will help you quickly screen for the solvent you are using, and specifically for anti-solvent crystallization, you can do the experiments in binary solvent systems and determine your anti-solvent for your anti-solvent crystallization. Then scale-up studies, you can compare the small scale analysis at 1 ml to the large scale and do the scale-up analysis. Then thermodynamic studies from the solubility curves, you can determine the enthalpy, entropy, and Gibbs free energy using different models and study the thermodynamics of it. What are the end user benefits of the latest version? So the latest version V3 has increased the limit of detection and improved transmissivity sensor. That means you can measure the lower concentrations and the higher concentrations more precisely. For the lower concentrations, you can go to even 0.5 mg for 5 mg per ml, and this is tested with carbamazepine compound. And for the higher range, you can go up to 1000 mg per ml. Then it comes with a new intuitive software, which makes it easy to program your experiment by just dragging and dropping these action blocks. Further, it has integrated software for data analysis. If you are using the older version of Crystal16, then you perform your experiment in one software, then you export your data in another software, Crystal Clear, for the data analysis. But with the latest version, you can do the data analysis during the experiment and, of course, after the experiment as itself, and in the same software. Then it comes with new feedback control, which allows for the reduction of experimental time. How it works: when your targeted transmissivity is reached, it will automatically go to the next step without completing the whole ramp. For example, here you are increasing the temperature from 0 to 55 degrees Celsius. With feedback control, it will automatically go to the next step when your targeted transmissivity, for example, here it is 100%, is reached, and this helps you save a lot of time. For example, just here for 2 thermal cycles, it takes 8 to 9 hours, which can be done with 5 to 6 hours with feedback control. Then comparing the two versions, Crystal16 V3 has increased the temperature range. You can go to -20 degrees Celsius or even -25 degrees Celsius with external chiller in all 4 reactor blocks simultaneously. Then the transmissivity range has increased. That means you can measure the lower concentrations and higher concentrations more precisely. Then the maintenance and serviceability has improved. It comes with the unibody structure. That means it needs less maintenance, less downtime, and less purge gas consumption. And of course, there is improvement in the software, the new intuitive software programming your experiments. Then it has integrated data analysis in a single software. Then user-defined automated clear and cloud pod analysis, and it has feedback control option as well. Now we will go to software, or before going to software, I will briefly tell a few things about tuning step as well. So tuning is an important step to measure your clear and cloud point accurately, which can be different for different solutions. The tuning step calibrates the system to 100% transmissivity. For example, for figure 1, the tune step will reduce the light intensity to match the 100% transmissivity, whereas in figure 2, the tuning step will increase the light intensity to match the 100% transmissivity. You can tune your system by 2 methods. You have to choose one. The first is the initial tune or the cold tune. So in this method, you tune the transmissivity sensor with a blank solvent. And this method is used for the compounds which does not change color throughout the experiment. Then alternatively, you can tune at high temperature when everything is dissolved, also known as hot tune. And this method is recommended mostly for the compounds which change their color or affect the reflective index of the solution. Then steps for the cold tune, you maintain at the same temperature for some time. Then you add a blank solvent. To add blank solvent, you can put a prompt step and then do the tuning step. And then again, with the prompt step, you can change put your actual samples. And then do your thermal cycles like this. Take care that you perform the tuning step once for each experiment. Then for the steps for the hot tune, you increase the temperature to some high temperature, maybe a few degrees below the boiling point of the solvent, and maintain there for some time. And then you tune there. But before tuning, make sure that everything is dissolved. To check everything is dissolved, you can put a prompt step and check the samples visually and make sure everything is dissolved. If everything is dissolved, you just click continue and do the tuning and further thermal cycles. Again, for hot tuning also, you perform the tuning step once for each experiment, and any transition points before the tuning step should not be considered for your data analysis. Now we will go to the software. Yes, so this is the software. Now it is connected to the instrument, and the connection you can check here with this green sign, and if not, you can click on this and just connect. There are some other options available, setting options here, which you can also check. Temperature, different kind of temperatures. Then the software version, if you have, this is the latest software version. If you don't have the latest version, then you can please go to the website and download the latest version. You can get some help information here, information about the software, and also the Crystal16 manual is also available. Then when you open the software, this is the first screen you see. And on the left-hand side, you see all the 16 reactors. And here is the information for each reactors, the temperature, possibility of top stirring and bottom stirring, and this gives you the status of the running experiment. If the experiment is running, you can see here running here. If the experiment is complete, you see a green sign here. And if it is idle, you can see it with this status. Now here you see all your files, open experiment files, the recent files, and here you can open your any experiment. We will start a new experiment by clicking on a new Crystal16 experiment. This opens your detail tab. So here we put all the informations of the experiment, like we are determining the solubility, and these username and description are optional. You can add anything you want to put. Then this is the option for feedback control. If you have the feedback control license, you will be able to enable this. If you do not have the license, then you will not be able to see this option. We will program a feedback control later, but let's first do without the feedback control. Then you see a cap type here. You select the type of cap you are using. If you are using the bottom stirring, you use the basic cap. And if you are using the top stirring, you use the overhead stirring cap. Then these are the 4 vials available. You put all the information about the vials, the compound you are using, the solvent, the concentration, the supersaturation, which is required when you are doing the induction time analysis, then the stirrer you are using, the bottom stirrer, the type of magnetic stirrer you are using, the standard type. Then we copy this from vial 1 to all the vials by clicking copy to all and change the concentrations accordingly. You should take care that this compound and the solvent name are same if their compound and solvent are same. If you are using a small w and it is because it is case sensitive, then it will consider this as a separate solvent. So you may get a separate solubility curve for this water and this water. So always take care that you are using the same caps. After putting all the details, you go to the next tab, which is program tab from here or from here. Here you program your experiments. The different actions available are here: the linear ramp, quadratic ramp, hold, prompt step, and the tune step. Let's first increase the temperature. To put it, you just drag and drop it here. And when you put it here, you get the different settings that you can put. For example, we are increasing with the linear ramp. You put the end temperature, for example, 60 degrees Celsius with the heating cooling rate of, we can go slow, 0.5. So the recommended heating cooling rate is between 0.3 to 0.5. You can go fast as well. And the duration will be calculated automatically. This is a sample interval. You can change it, but it is recommended to keep it at 1 second. Then the bottom stirring you want to put, and the recommended bottom stirring is between 800 to 1000 RPM. Then we keep it at the same temperature for some time, and we drag and drop the hold step, and we maintain it maybe for 10 minutes. Then we can put a prompt step to check any message. If everything is clear, check samples. And then if everything is clear, we do the tune step. Then we reduce, then we do our thermal cyclings by using another linear ramp. And maybe we want to decrease temperature to 10 degrees Celsius with heating cooling rate of 0.5 degrees Celsius and the bottom stirring of 800 RPM. And maintain at the same temperature for maybe 10 minutes and increase again to 60 degrees Celsius with heating cooling rate of 0.5 degrees Celsius and maintain again for maybe 10 minutes. This is one thermal cycle. We can repeat the thermal cycle by increasing the group repeat, or we can directly put some value here. So the recommended heating and recommended thermal cycles are from 3 to 5 times. The programmed experiment will also be visible here. You can see the graph here. Then I will go through these settings as well. So you can also import this experiment file if you have saved your experiment file from your library, or you can import from your experiment file as well. And also you can export this and save it and do the import it later for other experiments. After programming your experiment, you can go to run and results. And here you select your reactor where you have put your samples, maybe reactor B, and then click start. You can also schedule your experiment to start it later with the schedule start here. Let's click start. When it is started, you can see the experiment running here with this sign and with the bottom stirring. You can pause the experiment in between and go to the program and do any kind of changes with your experiment. And then again go to run and result and start your experiment. When your experiment is performing, you can see the live experiment in run and result as well here. You can zoom in like this and you can see your experiment running. And also in the analysis part, you will see your experiment running here as well. Now I will show you one file for the analysis, how to analyze the data. Maybe I can open a previous experiment. Yes, this is the experiment which was run for thermal cycles for solubility determination. And the details of this are, this is to determine the solubility of ascorbic acid in water, four different concentrations. The program was set to first increase, maintain, tune, and then 2 thermal cycles were programmed. In run and result, we can see the experiment when it is complete. And for the analyze, we go to the analyze section. Here we have the different options here, transition points, where we select our clear and cloud points. Then we can go to solubility for solubility and metastable zone width determination, and nucleation analysis if we are doing the induction time experiments. First, we select our transition points. We go through each while to select our transition points. First, we click on this settings, which is find all transition points. And this is by default, which is selected. We can use the legacy crystal clear as well, which is available in the older versions, but then you will not be able to change any settings. If we select the transition points, you will be change the settings here. First is the clear point threshold, which means anything value above this will be considered as your clear point. Then cloud point, anything below this value will be considered your cloud point. You can change these values as well, 70 degrees, 70% maybe. And then for how long this value is maintained. If this value 100% transmissivity is maintained for 30 seconds, it will be your clear point. And similarly for cloud point, if your transmissivity is maintained 70 or below 70, it will be your cloud point. After putting your values, you can click on find all transition point and click yes, and it will give your all transition points. Then each while, we go through each while to check our transition points. As earlier said, you should not use your transition points before the tuning step. You can exclude this by clicking on this and excluding here, or you can directly delete it by right-clicking on the graph and delete selected point. Then it is recommended to not use your cloud point or transition point on a hold step, because it will give you a wrong indication. So this also we can exclude. And this, we think if it is okay, we can move around here and check if these transition points are okay. Then we go to while 2 and again check our transition points. This we should not consider because this is before the tune step. We can exclude this. Similarly in while 3 and while 4. And you can manually add your transition points by right-clicking, and there are some other options available to change your transition points. You can export the data in Excel file by clicking on export. You can copy the image by clicking on this copy image to clipboard. After you have checked all your transition points, we go to the next step, which is solubility analysis. In solubility analysis, you see the graph of the solubility curve and metastable zone curve. And you can zoom in by clicking here, and you can play around with this. You can exclude this point by clicking excluding here or directly deleting it, and the values will change accordingly. Then you can right click on this and do some changes. You can change the temperature axis range, maybe 70 degrees, and the graph will change accordingly. Then below this, you have the solubility curve, fitting curves for cloud point and for the clear point. The functions can be the curve can be represented by Van 't Hoff equation, quadratic equation, and linear equation. Mostly for solubility curves, we use Van 't Hoff equation. Then you can change the color by clicking here, and the fitting curve is the equation is given here. Below this, you see the solubility table with all the clear and cloud points, which you see on the graph. You can arrange these by clicking on here on the basis of all your clear points or all your cloud points. Then on the basis of the solvent, in the increasing order, on the basis of your reaction temperature with increasing order. After this, you can just save your file in different formats here and just click export. maybe I can just show you the exported file. This is the exported file here. You see the graph, solubility and metastable zone width, then the four different concentrations that you have used, different transition points, clear point, and different transition cloud points. Then after this, I can now maybe show you how to use the multi-analysis. If you go to the multi-analysis here, the aim of the multi-analysis is to combine your different experiments. You can open your multi-analysis which you already have, or start a new multi-analysis. Here I already have some open multi-analysis. Maybe I can open this. Here in the details tab, you can add different experiments by clicking on add experiment, and you can add the experiments here. If you want to delete, click on this and delete the selected one. So in the analyze, you will have all the options of graph, the solubility curve, and the solubility table. This is the solubility of ascorbic acid in 3 different solvents. So you can compare directly the solubility in the 3 different solvents using the multi-analysis. If we maybe, you can remove it by clicking some of the curve, you can remove it by clicking on the legend above. And this gives you solubility, only the solubility curve ascorbic acid in 3 different solvents: water, some concentration of water ethanol, and some concentration of water methanol and water ethanol. And for each curve, you will get the equations and the functions and the are fitted values here, and all the transition points below. Now maybe I can show you one. Go to experiment, back to experiments. I can show you a feedback control experiment. For feedback control, this is an example of feedback control. We put all the experiment details here. If you want to do a feedback control, we enable this option here. When we enable this, we get this extra options to select, which is our target reached after how many, maybe 5, 6, 7, and the units are second or sample interval. Usually both are same, but it can be different as well. So maybe we want to keep for 5 seconds, and then the targeted reached for what we want to select for all the four vials, or where the first transmissivity is reached, or we can select any specific vial as well. Now, because we are using all 4 vials, we will select all. And these are the same 4 different concentrations of KNO3 in water. Then we go to the program. When we are using the feedback control, we will see these extra options: feedback control linear ramp, feedback control hold, feedback control quadratic ramp. If we use these, for example, here we have used this normal hold and did the tuning step, and then while increasing from 20 to 80 degrees Celsius, we are using the feedback control. So when we select this, we see some extra options here. When we are increasing, we see our transmissivity is increasing or decreasing. If we are because we are increasing temperature, we are expecting to increase our transmissivity to up. Then the targeted transmissivity, what we want to achieve, we want to achieve 100% transmissivity to be sure that everything is dissolved. Then the end temperature is the same, that heating and cooling rate, what we want to use, and then the sample interval and the RPM. Similarly, if you want to maintain the same temperature with the feedback control, we need to decide if we want to increase or decrease. Again, we are increasing the temperature, or we want to keep it at 100%. So we select the up here, feedback control up action, and the targeted transmissivity is again our 100%, and all other parameters are the same. While decreasing with the feedback control, we select the down option here, and the targeted transmissivity now we select as 0%, and all other parameters are the same. Now for the feedback control, we should take care that, for example, if we do not have this step here, for the feedback control, the end temperature, for example, here 20 degrees Celsius, should match the starting temperature here. The cycle should be complete if you are using the feedback control. That means if you are increasing the ramp here, so it will automatically add a extra step to make sure that the end temperature here match the starting temperature here. So we are increasing temperature from 20 degrees Celsius. So the end temperature should also be 20 degrees Celsius. So this will automatically, the software will add this step. Then we can just select any reactor and click start. It will start the normal experiment. But what will be the difference? I can maybe show you here. This is the solubility of KNO3 in using a feedback control. So this is the same program increasing from 20 to 80 degrees Celsius. So this is already experiment which was complete. So in the results section, we can see that from 20 degrees Celsius, it did not go to 80 degrees Celsius because the targeted transmissivity was already achieved here. And then it moved to the next step. Similarly here, the targeted transmissivity is reached here at 50, maybe 52 degrees Celsius, then it automatically move to the next step. So you can use this when you are not sure how much time or at what temperature it will dissolve. So it helps you save a considerable time for performing your experiment. I think this is all with the software. And yes, I think this is all with the Crystal16 training. If you have any questions, please feel free to ask. We can have a discussion on the different questions you have.
Thank you very much, Jyoti. We do have a few questions, but also if you are hearing us and you would like to ask a question live, please raise your hand or let us know in the chat, and we can unmute each one of you. I have, and indeed we will send the recording. I see already a question related to this. You will receive an email with where you can find the recording on our website or directly in our YouTube channel. I have a few questions, Jyoti. I will share them with you, and they are also related to the tuning step.
Yeah.
What if the hot tune is not clear? So what can you do about a hot tune?
If your hot tune is not clear, you can increase the temperature further and can maintain at for the same time. I can maybe show here.
But if you are, for example, Jyoti, already at the boiling point of your solvent, then you cannot necessarily increase the temperature, but make it maybe for longer time.
Yes, you can if you want to do the hot tuning. Maybe I can share this. Yes, if you are increasing your temperature and if everything is not clear, you should not click continue during the prompt step and keep it running for the same temperature for longer duration. And still, if you are not able to tune your system, maybe you can go for the cold tuning as well. So that is
I would say for longer time, and even visually really looking at the vial, take it out fast,
yes,
put it back, and keep it longer at that time. Mixing is also important. That and indeed, if the hot tune, it means that then there the solubility, the concentrations are not really okay.
Yes.
So then you should rely on an
cold
tune or a blank tune from the solvent.
Yes.
That you are going to use, you are using in your experiment. Just do a tuning with the blank solvent in the beginning of the experiment.
But if you are not able to dissolve it, then it will not give you the clear point anyways.
Anyway,
then maybe you have to decrease your concentrations.
Okay, so that was one of them. And then another one. What are the best practices to tune the equipment for each molecule? Do we tune at the high solubility solution or at the predicted solubility for cooling experiments?
I think, as already mentioned, there are two methods you can tune. You can use the cold tuning. So cold tuning is mostly recommended for this type of compounds where it will not change. And if you are using the hot, if your compound has some effect on the coloring of the solution, then it is recommended to use the hot tuning. But also, sorry. Also, we have some tutorial videos on the, maybe if we can open.
No, yes, those they can be found on our website, but I'm thinking now because this question is more related to the solubility, the solutions are more related a bit to the concentrations that you are using. We have a rule of thumb, let's say, when you do not know anything about your compound and how to set those concentrations to test. Maybe you can how to choose those four concentrations.
Yes. If you are not aware of, you have no idea what concentrations it will work, then it is recommended to use the solubility at room temperature. That is
just to do a visual. You can do a visual check at so you have 1 milliliter of your solvent and add slowly a little bit of the compound, shake it, goes into solution, add a bit more, and then you know more or less where you are at the room temperature, and then
you can use a concentration 0.5 times of that, and you can go 2 times and 4 times of that concentrations, and then you can program your thermal cycles.
In this way, you have the 4.4 vials to the concentration. So and because the question was also related to the tune, a safe way if you really don't know anything about it, and so of course you can also use predicted data, but mainly what the transmissivity, what the tuning does is to kind of like calibrate your instrument for the solvent, and each solvent has a different viscosity and different slightly different coloring, which will influence your quality of your experiment. So that's why we advise to tune. So also doing a blank only with the solvent, it also helps, unless, as Jyoti just mentioned in the very beginning, if your compound is also colored, then
use the same compound and use the hot tuning for those compounds.
Okay, more questions. Sometime when we do heat tuning after prompt step, the program automatically repeat whole step of tuning. So we have more duplication of hold tuning in the program, and program doesn't progress. Could you say why can we do to avoid that? I think this is an old bug, right? It might be that you do not have the latest version of the software. Yes.
Yes, you should check if you have the latest version, and also you should check if you have by mistake did a repeat here this thing, but still you have this problem. You can write to our service team. We will get back to you for this.
When doing a cold tune step, does the blank solvent need to match the solvent used in experiment?
Yes,
of course, because what it influences the transmissivity, so this calibration of the transmissivity of this light is the color, the viscosity, different of the solvent. So
yes,
please use the same.
Yes, if you're doing the cold tuning, it is recommended to use the same solvent which you are using for your solubility test. And also, if you're using your top stirrer, the hook one, then it is also recommended to do the tuning with the stirrer as well.
Hook agitation, so the stirrer, is it for basic cap or overhead steering?
That is for overhead steering. If you,
it is for overhead steering. So this hook was specifically developed to overcome grinding of your crystals. In some cases, by grinding your crystals, you can even induce polymorphic transformations. And also it helps on better mixing. So that's why the top steering, also we know at the larger scale, from the top does perform much better than the magnetic bar, of course.
Yes.
And what is the recommended number of points for a good solubility curve?
So the minimum are 4, and maximum you can use as many you want, but I think 5 or 6 would be good. But 4 are like, with the 4, I think it gives a sufficient good data to present your solubility. Yes.
And it also depends on the compound a lot.
Yeah.
If you have a problematic compound with very low solubility and so you might have to further tailor your experiments. And
yes, it also depends upon your R square value. Yes, if you in here, if you see if your R square value is more than 0.9, I think 4 points are sufficient. If you want to, if your R square value is not less than 0.7, you can repeat with more experiments as well.
Okay, what is rare earth? Oh, sorry, I'm running back, and luckily I sit next to Jyoti. What is a rare earth in bottom stirrer?
So yes, that is for to do a more strong mixing, more stronger RPM it will be. So if you have a compound which is not mixing well, you can use the rare earth.
Yes, so rare earth is the material that is actually in the magnetic stirrer, and you can identify it. It's usually they are white with a black dot on it, and create a stronger magnetic field, so it mixes much better. Also, this I wanted to add something. Sorry, I remember while I was listening to this training, you have mentioned, Jyoti, in the beginning about the recommended steering between 500 and 800, but it highly depends also on the viscosity of the solution. For very thick slurries, very viscous, almost like honey-like of materials, of solutions, usually what we say go in lower RPMs. So 100, 200, maximum 300, even. So don't go too high. If viscosity is not a problem, is very like a normal, like a solvent that mixes, and so like water or so, even oil, then you can go high.
800.
Yes, exactly. So you need to always have this in mind to not to splash everything around, but also to still mix well. So if it's too viscous, go low. If it's normal enough, what do you call normal? Yeah, more like water or oil type, then you can go to 500 to 800. Yeah. I think this is it in terms of questions. I'm looking if anybody raised a hand. No hand raised. I think this is it. Thank you very much all for joining. And I have a question here. A raised hand. I'm trying Leo to allow to talk. I'm still thinking, can you do it from your computer? Or Irina, if you hear me, can you unmute? You are unmuted. You should be able to talk now, Leo. Hello, do you hear us? We cannot hear you.
No.
Allow to talk.
Is something with me? Or if you, maybe if you can write your question.
Hello? Hello? No. No, we cannot. We will try to contact you directly, Mimon. Thank you very much for joining today. If there are any other questions, please write to us directly at info@crystallizationsystems.com, or directly to Jyoti or to me, to any of us, or to our support box, and we will be more than happy to further help you. Also, if you have an older version of the software, the same, our after sales department can help you installing the newest version no cost.
Yeah.
Thank you very much. Have a good day.
I would like to mention that if you have anything, you can go to our website and check these tutorial videos. And we have a lot of tutorial videos you can check if you want to know
a bit more about the tuning indeed.
Yes.
Yes.
Yes, I think that was all.
Thank you. Bye.
Thank you. Bye.